Here's a bit more of a complicated example. A movable pulley C is connected to two particles A and B of mass 4 and 7 kilos. The uniform string passes under C and is connected to both of the particles. The movable pulley has a mass of 20 kilograms. Find the acceleration of the movable pulley and the tension in the string. So, just to be clear before you go ahead and try this problem, let the acceleration of one of the particles, say A, have an acceleration of little a. For particle B, have them have an acceleration of little b, and C, therefore, the acceleration of C is the average of these two accelerations. So just keep that in mind before you start trying the solution. When you're ready, come back and see the actual solution. So firstly, here's a diagram of actually what's going on. So we have a particle here, particle A, it's 4 kilograms. It has a weight of 4g and the tension acting in the string. I have an acceleration of little a, and I've also denoted the normal reaction force as Ra, even though there's no friction acting on either of these platforms. The second particle, particle B, has a mass of 7 kilograms and has an acceleration of small b. So the tension will be acting in this direction, helping the acceleration in both cases. For the movable pulley, however, the tensions are acting directly upwards and against the direction of motion. So it's going to go downwards with a weight of 20g and an acceleration which is the average of these two accelerations. So after resolving forces, you get to this stage. So the tension in the first particle is 4 times a. So you can see it's just the tension is mass times acceleration. This is the same thing for the second particle. So the tension is just 7 times the acceleration b. For the third particle, we have 20g minus the 2t is 20 times the average of the accelerations. So 20g minus 2t is 10a plus 10b. Now, a key thing to note is that we have T, A, and B. So, in order to get the tension in the string first, is usually the way to go about these kinds of problems. We rearrange equations 1 and 2. So, dividing by 4, we get our first substitution, A is T over 4. And dividing by 7 in the second equation, we get our second substitution of B is T over 7. Now, substituting these two equations into this here equation, we get that 20g minus 2t is 10 times t over 4 plus t over 7, because you can factor out a 10 in this stage. So the 10 comes out, and you get t over 4 plus t over 7. So in simplifying and getting a common denominator, we get that this is 11t over 28. So multiplying this top and bottom by 7, and this one top and bottom by 4, you get 7t plus 4t over 28, which is 11t over 28. So after doing some simplification, we get that 560g, so this is after multiplying by 28, so 560g minus 56t is 110 times t. So I skipped a bit here, but 560g is therefore 166t. So t therefore is 560g, so 560 times 9.8 divided by 166, which is indeed 33 newtons. So that's the tension in the string. Now, usually we don't find the tension in the string first. However, we have found the tension in the string first here, because if you put them into A, so if A is t over 4, so the acceleration of A is 8.25 meters per second squared. The acceleration of the second particle is t over 7, so 4.7 meters per second squared. So the average accelerations, or the acceleration of pulley C, is just 8.25 plus 4.7 over 2, which turns out to be 6.48 meters per second squared, or 6.5 meters per second squared, if you're taking it to the same significance as g being 9.8.